And the others, the other photons, they just don't create anything. Magnification, this is exactly what we do for optics. That it's like the length of the image divided by the length of the object. And that is the magnification. And in this case, it's the image on the CCD. So most times CCDs are very small things, about 2 centimeters by 2 centimeters, 3 centimeters by 3 centimeters. And your objects are very large usually. So this is usually a very small number. But that's what the CCD magnification is, just like an optic. And then resolution, you want to make sure that your image has has at least, if you want to resolve 2 things, you need to make sure that the spacing between those 2 things is at least 2 pixels. So for instance, you're familiar with cameras that they have like 3 megapixels or 12 megapixels. Well, that tells you sort of what the size of the CCD chip is. So let's say you have 5.3 megapixels. If you take the square root of that, that's like 2300 by 2300 pixels on a side. So it's a square with 2300 pixels on each side. So that gives you the 5.3 megapixels. And then if you wanted to resolve something, you'd want to know, well, how closely are those pixels spaced? Well, you need to know how big the CCD is. So let's say that we have a CCD that's like 2 centimeters by 2 centimeters. Well, we know that on each edge of the square, it's 2 centimeters. If I know that there are 2300 pixels for those 2 centimeters, I can just do the division and come up with how many centimeters or how many meters there are per pixel. So in this case, it would be 2 centimeters divided by 2300 is 8.7 micrometers. So that's saying that these pixels are 8.7 micrometers apart. So if you wanted to resolve something, you would have to make sure that the 2 things that you're resolving are at least twice this distance apart. So that would be 17.4. You need to make sure that your image of those 2 things would be 17.4 micrometers apart. Does that make sense? Good? Good? Okay, Clark?
Yeah, fine.
Okay. So, okay. And for the quality, for quantum efficiency, if you have high quantum efficiency, you can take good pictures in the dark because every photon creates some photoelectrons. And for the pixel resolution, it really depends on how big the object that you're trying to take a picture of and what the size of your CCD is, and that basically will set how much magnification you'll need in order to be able to resolve things. And naturally, with all this, you need to be able to solve problems. So here's a problem. What would be the magnification that you need? This is like minimum magnification. If you have a larger magnification, that would work. You need to resolve 2 points that are 0.01 meters, so that's like 1 centimeter apart on an object. If the image is to be projected on a CCD square that's 3 centimeters on a side, and you have 8.0 megapixels in this thing. So how magnification would you need? One thing I'll suggest is how many pixels do you have on a side? Yeah.
Which like the square root of 8?
Yeah, the square root of 8. 8 megapixels, or so 8 million. So 8 times 10 to the 6. And what is the square root of 8 times 10 to the 6?
2,828.
2,828. We'll call it 2,830. Yeah, something like that. So that is how many pixels on a side. And then we know that it's 3 centimeters on the side, so we can actually figure out the spacing between the pixels. So that would be 3 centimeters, or 0.03, over 2830. And that will be
1.06 times 10 to the negative
1.06 times 10 to the minus 5th. So that is how many meters between each pixel. So if we want to resolve something that, so if we want to resolve something on the CCD, we have to make sure that the spacing between the two things has to be what? Twice this. Yeah. So, so this is our pixel spacing. So to resolve it, so I'll call it our resolution spacing. That has to be 2.12 times 10 to the minus 5th meters. So this is the distance on the CCD that we need the image to be separated. And now, if in reality these things are 0.01 meters apart, that tells us how the magnification we need. Because the magnification is the image distance. So the distance on the image over the distance on the object. So that'll be 2.12 times 10 to the minus 5th over 0.01. So that would be 2.12 times 10 to the minus 3rd. And so this is our magnification that we need. If it's bigger than this, that's no problem, because that would tell us that these points are going to be further apart. But smaller than this, then we wouldn't be able to resolve it. That's basically about it. I guess I have a couple more slides, but this is really the main part of it. Yeah, what else? Where do you use CCDs?
Cameras.
Digital cameras.
Like this
We're
one.
being recorded on CCDs. iPhones, absolutely.
Calculators.
Calculators.
But the ones with the graphing displays.
Okay, well, something that records an image. So,
Maybe not.
camcorders,
Just a
fax
thought.
machines, X-ray machines, astronomical machines. And I guess there's one other thing that you might need to know is how do CCDs compare with film? And the answer is really well. Because the CCDs, the longer you expose it to light, the more charge it gives you. And it goes up very linearly. If you're using film, it's not nearly as efficient. And if you look at as a function of time, let's say the charge, or sort of the image, a CCD goes up like that. Film sort of peters out. It does not go up linearly. So they call it reciprocity. And that is everything you need to know about CCDs. How you guys doing?